wait, is my camera on? Give me a second. There we go. Oh. All right. Oh. Okay. So, our paper is on analyzing and personalizing the learning performance of special needs students using machine learning and data analytics. And first, we have to understand, what is, special needs students and how are they doing right now? So the current education of special needs children is quite lacking. They're twice as likely to have less than a high school education, 40% more likely to only have a high school education, half as likely to only have a college degree, and half as likely to get more than a college degree. So they are kind of falling behind, not typically actually due to their intelligence, because most special needs kids are actually intellectually equal to their non-neurodivergent counterparts, but it's typically because they require special accommodations in order to perform at the same level, typically because they are less able to focus or are more easily distractible by the environment. And here are some of the symptoms of the learning disabilities. They are less able to focus, and they are more sensitive to the environment because maybe for some of the cases that I've seen, maybe it's because their clothes are getting a bit itchy, it's because the air is a few degrees off, or maybe just that the ceiling fan is pretty loud, and these all kind of contribute. They are really hypersensitive kids, so anything that is not perfect in their environment will kind of throw them off in their learning. And on the other side, they are more preferential towards interactivity. They love answering questions. They love doing activities. They don't really like sitting there and listening to other people talk. They kind of want to be more hands-on. Another thing is that they really prefer order in things. Typically, when you start a class with special needs children, you will need to prime them, which means you will inform them of the schedule of the class, what you guys will be doing. And for some specific cases, maybe even how long you will be doing the activities, such as hey guys, today we're going to be learning about machine learning. We're going to spend 10 minutes on this, 10 minutes on this, 10 minutes on this. So how do teachers accommodate them? Prime students, like I just said, to give them a schedule, to give them a sense of order. Frequently ask questions to keep the students' attention, either because they're getting distracted or just on the positive side to reinforce their learning, to kind of give them questions and then kind of give them positive reinforcement of they're doing well. Control the environment and keep out distractions. So maybe the room decor will be blander than a typical classroom, because any big flashy images on the wall could be a very big distraction to them. And try to close the door so that no outside audio is really getting to them, and they're really sensitive to the environment like that. Next up, which is the thing I feel like should be for all educators, but especially in this case because they get more easily distracted, you have to talk with a very lively tone, because or else if you talk monotone, they get very distracted and can start wandering off doing all sorts of things. Now, in our circumstance, there's also an issue with the current special education, and the first is availability. Even though by law it is required to provide, they are typically very difficult to find, especially in quality. And very few educators are really trained with the accommodations for special needs children. So many times they are not fully equipped to handle these children. Another issue is capacity. Since you have to be more focused on what all of the students are doing in this circumstance, it often requires the class size to be smaller. And teachers have to be more aware of how attentive the students are. And once again, like before, it's easier in a smaller environment to ask more questions and control the environment, stuff like that. Now, the approach we're going to take to help this is an engagement detection algorithm with a teacher interface on the other end that could assist the teacher in kind of telling them when the students are engaged or disengaged to better help their abilities to assist these kids. So that maybe when a kid is distracted, they can see it on the web page and then just go like ask them a question to kind of redirect them back to not lose them. Now, a limitation with using an algorithm for neurodivergent children is they react very differently to stimuli on pretty much a case-to-case instance. So we can't really use a really sophisticated algorithm for these kids because it will typically fail because they all disengage in different ways and they all engage in different ways. So we chose a simpler algorithm to ensure that it will be more usable for more people. And here's the solution we came up with. Here's the full flowchart. We have the webcam on the student's end that will feed data into the student client. This client will then process the data and send it to the database. This database will then send data to the server, and then we will also have a front end web page that will be displaying this information and constantly exchanging index with the server. So it's a pretty simplistic proof of concept flowchart. And here are some of the results we got. We ran this on 2 classes of really small size, and we got some decent results in most cases. From class 1, student 1 and 3 seemed to be really accurate, and the way we did this is the top bar, the detected result, is the average engagement, like how much they were engaged throughout the class. That is the data is provided by our algorithm. The second is estimation by the teacher, and we kind of see how these 2 data compare. In most cases, it did pretty well, but also I would like to point out the outlier here of student 2, who is not detected as engaged most of the time by the algorithm, it looks like, but in reality, according to the teachers, they were actually relatively more engaged than detected. And this is one of the cases that I talked about just now, where the algorithm can't work for all cases because everybody disengages differently, engages differently. Maybe the algorithm didn't detect the engagement of student 2 perfectly because they had a kind of different way of going about things. So that's on the student end. It appears to be relatively accurate. And then we also got some teacher feedback for how they felt about the system. And the general case looks like we are pretty in the middle with this system currently, where most things are pretty well done, but then also there is a lot that can be improved on. So speaking of improvements, oh, by the way, we use the usability scale to determine to be used in the survey. Speaking of improvements, we have some future developments that we would want to make. For example, improving the clarity of the user interface, because currently it's pretty simplistic and we only have the words to show, but in the future, maybe we add a colored background to it so it's easier to detect. You don't have to read the full word. It's just green or red, and it will help out a lot in terms of making class sizes larger. We want to make the system easier to use because currently you have to download the algorithm onto all the student side laptops and webcams, and that's an entirely cumbersome process that could take a while. 3, we want to improve the accuracy of our engagement detection. As seen before, it did pretty well in these cases, but we don't have that large of a sample size. And in the future, we want to make this more accurate and hopefully work for more people. 4, we want to optimize the algorithm in the future, make it a bit more accurate and make it a bit faster so that it won't be this giant program that you'll have to run on every laptop. It'll be maybe smaller. Or the alternative 5 is to make the system fully web-based, which would be also really nice, to skip the downloading process on the student side completely and to favor a more just web-based approach to kind of make the system easier to use for more people. Conclusions. So we made a system that would monitor engagement to assist the students in participation. This, in a practical scenario, would allow for easier accommodations for teachers so that maybe we could have more teachers who are familiar with special needs education and could provide these kids with a more helpful and fruitful learning process. And on the student side, if we can kind of prime them and ask them more questions, and they will be more engaged typically, this will assist the students in their learning process, and they will also be able to learn more. Thank you. Any questions or comments?